Hello and welcome to MerMaid Lab's software training. Today we're going to go through a general overview of the software. The first thing I do when I open up my software for the first time, I open up the options window and change my default language to English and my engineering units to the selection of my choice. I like length to be in inches, I like the rainfall in inches, pressure PSI, volume efficiency, US gallons per watt hour, temperature, Fahrenheit, area in square feet, volume, US gallons, and my flow is going to be in GPM. We also can select MGD if you'd like. Hit the apply button, hit OK, but I did want to mention to you, you may have missed this, it requires the application restart to be effective. So we're going to shut down the application and just do a quick restart. Now that we have all those settings changed, I'm going to go ahead and show you where you would go to start a new station file. Click on the icon and then put in the pertinent information for the station, hit next, and continue to follow the panels until complete. But today we're going to open up an existing station file, Mill Creek Lift Station. I picked Mill Creek because this is a very good lift station. There is no problems with it that I could find within the data. So I'll go through all the aspects of it. The first thing I want to talk about though is the properties section. In the property section you see the file name and its extension. I'll open up Mill Creek, which is where you would select a date range if you're looking for particular date ranges to view in your reports. So you can click on a month's worth of data, a week's worth of data, just a day's worth of data and analyze them. You can break them up if you need to. Okay, your initial layout shows what you did in the initial settings when you set up the station file, what they were. So if you have to go back and change this at a later time after you've done your flow study, you found that your levels were a little bit different, or it actually wasn't a 10-foot well, it was an 8-foot well, you can change this to 96 inches. You can do this, and you can also change how you're monitoring. This one's measuring from the bottom of the well, so there was transducers used in this lift station. So the pressure transmitter was reading 18 inches, 48 inches, and 60 inches. If you measure from the top of the well, it would be just the reverse, and you would select measure from the top of the well, and then the largest number would be at the bottom. But we're not going to change that. We're going to leave it at the bottom of the well. Also, you can go in and if you changed out in the field your information on your sensors, I'll click on motor 1. We had motor 1 here. You can type in a description of motor 1. This could be flight pump number 1 if you want to. But I like just putting pump 1 and then pump 2 instead of motor 1, motor 2 on my reports. I also, on motor 3 on this device, I understand that we were monitoring voltage. So the rep actually put voltage in here so that his reports will show voltage instead of motor 3. And on the voltage input, it's set for AC volts, and it's a Y connection. If you notice, motor 1 or pump 1 was AC current, and this means it was a 3-phase, 1-phase, 2-phase, 3-phase. When you click on this button, then this becomes a Y connection or a delta. Let me go back. Voltage. Now you can select Y or delta. We're going to leave it at as a Y. Also, you can go in and monitor your or look at how your analog setup was. But you always have to be connected to the data logger when you set your analog values up. And we'll have a video on setting up analog values and setting up transmitters in the future. So we have digital inputs, and you can name your digital inputs. And most of the digital inputs that we use are for troubleshooting, for monitoring when you have an issue within a control panel. You could use your digital inputs. And then you have your rain gauge. And you have your pulse input, and we can also call that rain. And then it's going to measure the total. It's 1/10 of an inch for pulse, done by the hardware. Set OK. You notice now it says rain. Okay, now in the analysis section we have two different types of reports. We have the electrical analysis reports, includes the motor summary, analog chart, and digital events, and the lift station analysis, which is your flow and rain information with a monthly report, your inflow and infiltration, which will give you your daily reports, and your overall evaluation report. I'm going to go on to the evaluation report. The evaluation report gives me a snapshot of everything that's taken place within the station and evaluates it. It has the beginning to the end of the data that we're going to be looking at. Remember, we set that up in the properties. Okay, so this is the file, how long the file is. It's about 2 weeks worth of data. Okay, Kurt Hastings of our rep Covenant Flow is the one who did this flow study. And you have the information about the type of well that it was in. It was a cylinder, it was 122 inches, of course it's a 10-foot, and then where the pumps turned on and what the volumes were. The MerMaid system and the software calculates the volume based on the levels and the dimensions. The electricity, actually on the electricity we look at the computed voltage for the it says the voltage was computed. That means that we actually used a step-down transformer and monitored this through Y connections. So this was the actual phase of each of the volts coming in. You know, 286.8 volts, 285.3, 287.2, and the balance, if it's unbalanced, by how much. You see that the pump 1 had the highest degree of unbalance. Well, excuse me, pump 3 did, but it's only 3%. Once you get above 8 to 10%, then it becomes a very concerning issue, because it also is going to change your pump capacity, and the amount of current that's being used at the station is going to go up, which is going to give you a higher electrical cost. You have your average. This is the average volts, and this is the average current for each pump. Your runtime information starts 205, 203. No suspicious events. This is uncommon. We normally have suspicious events on all lift stations. Okay, the efficiency is breaking down the kilowatt hours per pump per phase. It also shows you your events again and your hours, but it also gives you your pump capacities. This pump capacity for pump 1 and pump 2 is the average pump capacity for the entire time of the report, from 4:09 to 4:23. That is the average pump capacity that was for this station. It also tells you what percentage of volume each one pumped. Pump 1 pumped 50.4% of the volume, and pump 2 pumped 49.6% of the volume. And these are the volumes times 1,000. So it's 338,000 gallons, 333,000 gallons. Now the US gallons per watt hours, taking our wattage information versus the gallonage, and it gives you an efficiency number, 1.46 and 1.54. These are very good, but you have to know up front what the efficiency was to know if these are good numbers. I've seen numbers down below 1, and that's always interesting because that's usually an inefficient pump. But pump's efficiency can go as high as 4.0. The average cycle time is shown here. Pump 1 cycle time is 3 minutes and 49 seconds, and the average cycle time for pump 2 is 3 minutes and 38 seconds. Very good information. Both of these are very close to each other. It means these pumps are in good shape. And I understand from the rep that this was a fairly new station. What we do with the annual energy cost, over in this tab section, we put in the customer's cost per kilowatt and a power factor. Now I've put in a generic power factor of 0.9 because I know 1.0 is is basically no resistance to the motor whatsoever, and it's basically running the motor in outer space. But a power factor of 9 or less is typical for most lift stations. The power factor for this station, being brand new, is probably 9 or maybe 0.9 or maybe a little bit higher. But it's not always the case. Now when you use those numbers, especially the electrical costs, what we do is we take the electrical costs and the power factor and we calculate the annual cost to run each pump in this station. So the total cost to run these two pumps in the station annually would be $895.82 based on the cost per kilowatt. We also take each individual pump and say if you just ran pump 1 for a year, it would cost $919.23. And if you just ran pump 2, it would be $822.02. Now, to get this number, which is the extra cost, or the modified, if there were no modifications occur, that is, we look at the calculated annual cost for both pumps and subtract the most efficient pump from it, and that gives us $24 here. That's not a reason to even go out to the station. This is a very good station. Its cost analysis is looking very good. The efficiencies are looking very good, and the balance and unbalance on the motors are looking extremely good as well on this station. And that's your lift station evaluation report. Also, your lift station evaluation report can be printed off directly or saved, exported as an Excel, PDF, or Word document. Okay. The other one I like to show you, I'll go to the inflow and infiltration report. In inflow and infiltration, you see we have the diurnal flows of each day. Let me go back to one that shows the green. The green is the average flow per day for the length of the report. So what we're doing is averaging every day's flow and giving you a graph in green. Now the actual flow is in red. And of course, when it overlays on the green, it becomes brown. So this is the actual flow for the day. And you can put your cursor on it and it can show you exactly what it is. Here it's showing 79.6 gallons a minute, and the date was 4/10 at 4:45 p.m. And then you see that the actual flow is below the average flow for the week. And you can go day by day and look at the flow events. Now you can also click on the calendar here, drop down menu, and go to a particular day, like the 17th. Okay, I'm not going to get too detailed into this report, but you also have a readings report. And in the readings report, we can go to the maximum flow days. It does it in sequential, what was the highest versus the lowest, and you can pick a day, and it goes directly to that particular day. So you have that ability. You also show a sun with a cloud on it. We can look at the wettest versus driest days in here as well. Unfortunately, this particular station file did not have a rain gauge attached to it, so there's no rainy days to view. If you click on readings again, that will disappear. Now, one of the other things I want to show you about this report is that you can actually go to your taskbar, open up your task, and go down, and you can view your outflow by pump cycles. When you highlight this and click on the report again, the taskbar will go away. Then you click on 1 day, 100% view to reset the scaling. Okay, now you see your pump capacities versus your flow rates. This station is, I consider, a very good station because you have a much higher pump capacity than you have as an average flow rate coming into the station. I don't see any I&I issues here at this station whatsoever. You can also look at this in a weekly basis, so you can see the trends and where the pump capacities are. And you see it sometimes one of your pumps, which is pump 2, has a higher capacity than pump 1 for a short period of time. And that could be caused for several reasons. It may have had a slight rag gotten into the pump for a short period of time, and then it started moving back up again. Okay, that's the end of the infiltration. Oh, before I end this, if you want to do a report on this, all you have to go is to the report button. You can look at the report as you see it. It's just a graphical report. You can do a readings report with just the digital information, or a detailed report which combines both, and I'm going to show you that. And I'm going to look at, instead of all the data, which is the entire time frame of this flow study, I'm just going to look at the visible days for you to look at. So I'll click on the report, and it will generate a report and give you the information of your flow, the time in half-hour increments, what the average was, and the variations in flow. And down at the bottom, however we had the task set up, we're looking at the flow rate with the pump capacities along with it. If we wanted to, we could go back to tasks. Variations are good. Turn off the outflow by pump cycle. 100% view. Now we see without the pump cycles, and we can go ahead and do the same thing we did before. On this report, I'm just going to do the a standard report, which is the graphical report. And this is your graphical report done in a landscape mode. Well, it's actually not in a landscape mode, but this is the report. So there's several different options here to view the data and to provide reports on the data. Now your flow and rain report also has at the bottom the monthly report. The monthly report is what typically is everybody is interested in, because it gives the 1 month analysis of the station, gives each individual day, if there was any rainfall, what the volumes went through the station per day, the average flow rate, the maximum flow rate, the time it occurred, and then pump capacities, how many starts on each pump, and how much time was on each pump. And then if you had combinations of pump, where you had pump 1 and 2 on, all that information would be there as well in the monthly report. Again, this report can be printed directly or put into an Excel, PDF, or Word format. Now, if I go straight into the flow and rain report, you're looking at the timestamp data that's taking place regarding the pumps. There's a lot more data being recorded out at the station, but this report is giving you the timestamp data for the pumps themselves. So you see when a pump turns on, the date, the day, the time, and the duration of the period. Okay, so this for pump 1 turned on for 3 minutes, 38 seconds, and 17/100ths of a second. And it turned off at this time, and it was off for 22 minutes, 2 seconds, and 61/100ths of a second before pump 2 came back on again. Now that we have the volumes based on the dimensions of the well and where the off and on is, the calculated volume for the drawdown or the fill-up cycle is a bucket and a stopwatch. This is the average flow rate of the inflow for that cycle. For 22 minutes, the average flow rate was 66.6 gallons. Okay, now to set a pump capacity, which is the outflow, we look at the inflow rate on either side of the pump capacities and start setting the pump capacities, and then we tune pump capacities and give the most accurate flow rates. You can scroll down and look at the flow rates changing. If there was any anomalies in here, they would be in orange. They would show up, and anything under 10 seconds will not do a calculations. We basically throw it out, because we know that anything under 10 seconds in this station as an average or default is most likely not a true event. It was either maintenance being out at the station or something happening with the control panel that shouldn't have. And we don't want to calculate flow based on a pump just turning on and turning off for 10 seconds. Actually, we have a couple conditions like that. Here's one. This condition lasted for 47/100ths of a second, and then again for 10/100ths of a second. If you notice, there's no calculation here, and we don't use this calculation or data that's brought in here to do any modifications to the pump capacities. But typically you'll find something like this in every station. But these, I believe, are the only two that we saw on this station from start to finish. Also, you can look at, now we'll go back to the top here. You can, if you click on reports, it will regenerate the monthly report. But we've already gone through the details of the monthly report. One of the other things that you can do with this particular report is under the display, you can look at different summaries and periods. Right now there's no group by the summary. I'm going to put by the day. Now the other thing I want to do is I want my period to be, say, every 4 hours. And you see now I have 4-hour increments, and I have the averages per 4 hours, and I have more information as well. I have actually run times on the pumps and all the events and all of that information here. Now what we can do with this data, we can also add a summary of periodic summary or grand summaries. The grand summary would be a total, and the periodic summaries would be per day, and I want to click on periodic here. So now you see the total per day, and all these summaries are already generated for each day. Now what you can do is you can go over to Excel and export this file in an Excel format. I'm going to do it in Excel with colors, and I'm going to call it, it's going to put it in my documents library. I'm just going to call it XYZ test. Okay, and I want to hit save. I'm going to minimize my screen and go to my Excel platform. Open up a new file, and this file is in my documents library. I've done this a few times, but here's XYZ test. Click on it, and here's the information we were looking at in 4-hour increments. So this is an Excel spreadsheet. This is pre-generated by the MerMaid software. Also, it has the information link on the particular station, so there's some additional information that can be put in this field. Here's all your data. Also, once you change your display, you can actually click on display several times and it will go through. Now it's daily, then weekly, monthly, and then back to the original screen that we went to. That's the 3 lift station analysis screen. Now I'm going to talk about the motor, analog chart, and digital events. I'm going to start with digital events. Digital events is a very simplistic graphical display of how the events occurred. We can look at a week, and these are actually the starts of the pump. This is the voltage across it. This is the battery voltage. And then if you had any digital events, this is where you would use your digital events. If you're troubleshooting a control system, you can look at it and see how the events, you can actually drill in to a certain time slice and look at how the digital events, if you're recording different points in your control panel to troubleshoot a station. And that's what we typically use the digital events for. Now the motor summary. The motor summary is going to give you all the summary information about the motors. It's going to give you your electrical analysis of the station, your phase information, your average, your peaks, and all that information, as well as a little bit of a graphical view of how the highest amperage of each phase was. And this is the voltage. Remember, motor 3 was voltage. If you didn't say it was voltage, it would say motor 3 here, but this is the voltage over here. So you'd see if you lost, if one of your legs was short. Also here, this is the actual average for the entire duration of the station run. In other words, this is the amperage for the entire report. In other words, the average amperage, the off time and the on time. So that's the motor summary. The summary I get the most information out of is the analog chart. The analog chart right now, I'm looking at all 3 phases of pump 1. But I'm going to right click on my mouse go down to analog presets, and I'm going to go to current. Now when I look at current, I'm looking at the current from each pump, the actual average current of each pump, and I'm going to drill in by using my mouse and just looking at a particular selection here. And it shows me this is pump 2 and this is the current, including the inrush current. If I hit 100% V, which is rescaling my chart, you see that it scales it up to 150. These pumps, actually, the inrush current went above 150. We're reading 152, but we can look at each individual one if we wanted to. Now also, when we first came on with this chart, we also saw that we were looking at motor 1. Now when you look at motor 1 and it's drilled into the same time frame, actually the same time frame, we're actually looking at all 3 phases for motor 1. Here's, phase 3, the red is phase 1, and the gray here is phase 2. So you can look and see if there's an out of balance. You may see one of these phases way down at the bottom here, or missing completely. I've seen that many times where you actually lose a phase on one of your motors, and that's causing some serious problems to the motor and also to your electrical bill. Of course, you can scroll down and look at each individual one if you want to. I like to look at 1 day, 100% view, and then I tend to scroll over and look for anomalies if there is any. And the evaluation report usually kind of gives me a flag if I need to go and look at this in detail. Also in the analog presets, you can look at temperature. We can also look at the analog information. If we had an analog device set up in our data logger, this is where we look at the graph of the analog information. And that's a general overview of the software. Thank you for your time, and if you have any additional questions, feel free to contact me at any time. Thank you. This is Gary Kerr with MerMaid Labs.